Hey everybody, Dave here with Audora Audio, and today I wanted to take a look at wave sequencing. So I haven't made a video in a while. I've got a new setup and configuration, and I wanted to give that a try, and I really wanted to try and start making some more videos as well. It's been too long. So yeah, let's just kind of jump right into wave sequencing. So with wave sequencing, what you need to be aware of, I think it's one of those features that are fairly underutilized in the Kronos. It's very powerful. There's a lot that you can do with it, and I'm going to kind of show you what all of the parameters do, how you can apply them, and maybe some use case scenarios. So first off, what the heck is wave sequencing? Well, wave sequencing in its essence is really just a sequence of boxes that happen in time, and you can trigger a waveform within those. That's basically what it is. And so when we look at the Kronos itself, it's not something that you find in program mode, it's not something that you'll find in combi mode, but it is something that you'll find in global mode. And you actually have to hit the wave sequence tab to get to your wave sequences. And by default, you're probably going to start out here with this orchestral. Okay. What I'm going to do though is I'm going to go to a plain one, a blank one. So an initialized wave sequence, and it's going to sound like this. It's just going to be this repeating piano. Okay, so let's take a look at what all of this stuff is, right? So right off the bat at the very top, you have your wave sequence, and this is your wave sequence name. So this is, you can think of this like as the wave sequence equivalent of a program. In this case, it's FF init wave sequence. So this is just blank. We've got our mode. So we've got time mode versus tempo mode. Time mode is a static time-based mode where you can set the durations of individual steps. So going from one step to another, you can set that entirely based off of time. So, you know, in like 10 millisecond increments, it's like 240 milliseconds, 120 down to like, I think 10 or 0. Tempo, however, is based off of the internal clock of the Kronos. And so, or well, technically it's any MIDI clock that's being generated. So if you've got the MIDI clock set to external instead of using the internal Kronos MIDI clock, then that's where it's going to pull it from, but it's based off of a MIDI clock somewhere. And by default, it's going to be using the Kronos. So I'm going to set this Kronos to 90, and here's what it would sound like. Okay, so we've got, you know, a trigger every, you know, 3/4 of a second. Okay, if we were to set it to 60, it would be every second. Actually, it's a second and a half, but, or no, 3/4 of a second. And this is every second. Okay, so let's talk about some of these parameters and these steps and what all of this stuff is. So up at the very top of the screen, you have your steps. And you can have up to 64 individual steps, each one with its own set of parameters, its own control, its own functions, and so on. The step here is the step that you're analyzing, and so you can see what the multi-sample is. You can see the sample itself. So in this case, it's an acoustic piano mezzo forte, and it's the left channel, but technically it's still in stereo because that multi-sample is a stereo multi-sample. It knows to use both. And then this solo button, and we'll talk a little bit later what that solo button does, but it basically just isolates one of the blocks and allows you to listen to it by itself, and I'll show you examples of that later. So we've got this feature here that says key sync. And what key sync does is it allows you to synchronize your playing. It's not that it synchronizes your playing, but it's going to synchronize the time based off of when you start the note. So for example, if I purposely play a chord off time, okay, it's going to trigger all of those notes entirely based off of when the initial trigger happened. Right? So you can get some pretty haywire stuff going on there. If we were to turn key sync off, what's going to happen is it's going to quantize every note, not the initial note. So the first note that you play, it's going to start when you play. Every note after that will trigger when you play, but the note itself, when it repeats, will repeat on a quantized chord or on a quantized time. Okay, so now part of this quantized triggers button down here is entirely tempo dependent. So the way the quantized trigger works is for it to quantize, it needs to have a tempo that's being assigned. And in this case, it's going to pull the tempo from the internal Kronos, like the MIDI tempo. So this quantized triggers, what it does is instead of having that initial note on, I mean, that part's true for your very first note. Right? I can trigger all I want. But what will happen when I'm in tempo mode, okay, is that it's going to quantize the triggers for every note that I play afterwards. So if I start here, okay, I'm not playing these perfectly on time intentionally, but what's happening is it's not triggering the very first time when I play, it's only triggering the notes that are quantized as I'm playing them. Okay, so this is how the quantized triggers works. You'll notice it doesn't work in time mode. It kind of acts like key sync there. And the reason it does that is because there's no predetermined, kind of frame of reference. It doesn't know where the notes are supposed to be. And so what happens is when it triggers a note, it's going to be triggering it arbitrarily. So that's why you have to use the quantized triggers under tempo mode. Now another thing is the swing feature. So swing is basically taking your starting note and taking the offset of quantizing and then moving it. And so when we have the swing set to 100%, okay, under time mode, again, not doing anything, but in tempo mode, it has that grid that it can kind of snap things to. Okay, it sounds awfully slow, but it's there. Let me change it to 120 BPM, and it's just, you can hear it more quickly. If we set the swing to 200%, what's going to happen is it's going to take this grid that we moved by half before, it's going to move it by 3/4. It's going to move it even further. So it's going to be more like do, 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 do. Okay, I was a little slow, but you get the idea. We can set the swing as high as 300%. And what this is going to do is this is going to take that grid and slam it into the beginning. So the first note you're going to trigger, and then the second and technically the third notes are going to trigger at the exact same time. We haven't changed the sound, so it still sounds like piano both times, but the second, third, and other following repetitions are going to be triggering multiple notes simultaneously. So that does have kind of a benefit potentially, depending on how you're using it. But generally speaking, I just leave the swing off unless it's required. Okay, so let's get into this lower field that says wave sequence. So under the wave sequence field, this is our start and end steps. And so these are going to be, and you'll notice it actually changes on the upper field that puts this kind of box around these step sequences, these steps. And we're basically saying this is where the beginning is, this is where the end is. Now, first off, if you have loop enabled, which I do by default, your repeat times is telling you if loop is enabled or not. If we set this to 0 or set it to off, basically, what's going to happen is it's going to start at the beginning step on your step sequence and go through all of the remaining steps. Now, I've got this run feature enabled, and I kind of bypass that at the beginning. This run feature is saying, do we run the step sequencer or not? If run is off, what's going to happen is it's going to run the first step. That's it. If we set it to run, it's going to run through all the steps. So however many steps we have in our start, like our start step and our end step. Okay, so it did it for 16 steps. If I set this to 4, it's going to go 4 steps. And that's it. Now, we have something that's called AMS, which is alternate modulation source. And your alternate modulation source allows you to modulate something. Now, in this case, AMS is currently assigned to the start step. So for this to make more sense, what I'm going to do is I'm going to go into my step parameter page, and we'll talk about all the stuff that's in here later. I'm going to make different sounds. So I'm going to choose like an organ sound, and then following that, I'm going to choose a mallet, like a kalimba, and then following that, I'm going to choose like a piccolo. This is not the first time I've recorded this video poorly. There we go. And so if we listen, there, so we've got our 4 steps. Okay, and if I were to turn repeat back into infinity, it's repeating the piano over and over and over. Well, why is that? That's because over here, our loop start and our loop end are the same. So if I actually set this to 4, so our loop starts on 1, and our loop ends on 4, and they don't have to match your wave sequence start. So for example, you'll notice in this window up top, my loop is kind of that filled in blue, but the frame that surrounds all of these steps is my actual start, my loop, or excuse me, not my loop, but my step sequence my wave sequence, kind of, this is the box that we're working in. So I'm going to set that to 6 just for giggles. But what's going to happen is, because this repeat is set to 4, to infinite, and the loop end is on 4, it's just going to repeat the first 4 over and over and over. So even though we have the wave sequence set to end on step 6, the loop is infinite. It's never going to go past step 4. Now we could change it to like step 5, like 2 to 5. So what's going to happen is it's going to start the first sequence and go through the 4, like, so if we were to name them as numbers, so it'd be like step 1, 2, 3, 4, 5, 2, 3, 4, 5, and it'll go 2, 3, 4, 5 forever. And that's kind of how that loop works. And we're going to get into more details, but I digress. So this alternate modulation source allows you to change what the start step is. So the AMS, I'm going to set to ribbon. And I'm going to say I want it to modulate by, let's say, 4 steps. Okay, so nothing happens yet until I move the ribbon. Okay, so this is a problem because right now the pitch of the ribbon is being inherited by the last program I was in. The last program was the piano, so I'm actually going to change it intentionally. I'm going to go to an initialized program. I'm going to go to the oscillator pitch page under oscillator 1 pitch. This is kind of like your pitch common stuff. I'm going to set the ribbon to 0. And now when I go into step sequencer mode, the ribbon doesn't do anything. I mean, it's not that it doesn't do anything. It just doesn't affect the pitch. So what I've done is I've said my start step is going to be dependent on the ribbon by this many steps. So the intensity is how much is it going to change by, right? Now, because the ribbon is both it's negative and positive polarity, meaning it can say in the very center of the ribbon is 0. If you move to the left of the ribbon, that's going to be like negative, up to 127. And if you move it to the right, that's positive 127. Well, because this intensity can't, well, I guess it can go lower than, it can actually go lower than 0. So what we could do is we could say I want my start step to be like step 3, and I want the intensity to be 3. So it should give me the ability to kind of go before and after. And what's going to happen is if I turn this run off, I can use the ribbon to determine what my start step is. My step 5 is actually a piano as well, so I'm going to change that to something else, like a trumpet. I really want you to be able to hear the difference here. And there we've got a voice. So just that simple, by turning run off and setting my wave sequence starting, at a certain point, I can have my ribbon purposely determine what the starting note sounds like. Okay, so that's kind of neat. And so with this alternate modulation source, it doesn't have to be the ribbon. It can be all kinds of things. It could be something like your velocity. And your velocity, right, depending on how hard you play, will play different notes as well. So that's kind of a neat thing that you can do. Let's say for some reason you wanted to have an HD1 program that had more than 8 layers of velocity intensity. You could absolutely use the wave sequencer and use those different waveforms and say, well, I want 64 layers of intensity. So you could have, your velocity set to 64, I guess 63. Your start step is 1 and have up to 63 steps, and you could have different waveforms so that, it's absolute and utter chaos depending on how hard you play, right? Right now, they're mostly assigned to the piano unless I play really quietly. No. So I'm trying to, be super accurate, and I can't do that. But so this is the idea, though. Anyway, is that you have this ability to control where the start step is based off of some sort of modulation. Okay, so I'm going to turn this back off. I don't need that. Let's set that back to 4. We'll set the intensity to 0, although it doesn't matter. We'll set this back to run. Okay. And we'll set our loop step. Let me see here. Start 1, and we'll do 4. There we go. Okay. So taking a look at our repeat times, this is exactly what it sounds like. It's how many times are we going to repeat, and what are we repeating? So the loop start is, let's make this back to 6. So we've got a 6-step wave sequence. And then what's going to happen is we're going to number them as 2, 3, 4, right? Even though they're different sounds. Okay, so what's happening is we're starting on step 1. We go to step 2, 3, 4, but it's infinite repeat, so it just goes 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, forever. 1, 2, 3, 4, right? 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, and it continues. Now, we could do something crazy like change the direction. Now that's forwards, 2, 3, 4, 2, 3, 4. We could say backwards. And what's going to happen is it's going to go 1, 2, 3, 4, 3, 2, 4, 3, 2, 4, 3, 2. So 1, 2, 3, 4, 3, 2, 4, 3, 2, 4, 3, 4, 3, 2, 4, 3. Okay. We could also say backwards, forwards. And what this is going to do is this is going to go backwards and then forwards. So it's going 1, 2, 3, 4, 3, 2, 3, 4, 3, 2, 3, 4, 3, 2, 3, 4, 1, 2, 3, 4, 3, 2, 3, 4, 3, 2, 3, 4, like that. Okay, and so that's what the direction does. Now, if you're to set it, it doesn't necessarily have to be infinite. Like maybe what you want is you want it to go 1, 2, 3, 4, 3, 2, 3, 4, 5, 6, right? Pretend that's what you wanted it to do. What you could do is you could set your repeat times to 1. And what's going to happen is it's going to go backwards and forwards through whatever. And once it's done, actually, this one is probably going to go 1, 2, 3, 4, 3, 2, 5, 6, because what's happening is this direction is going to go backwards and forwards as it was told. And once it's done that, it just skips to the next step, right? Which is 5, 6. So if we were to slow this down, let's set it to 60 so we can kind of follow this a little bit more closely. What I'm anticipating is it's going to go 1, 2, 3, 4, 3, 2, 5, 6, because we told it to go backwards between step 2 and 4, like forwards and then backwards. No, okay, that's cool. So what it did is it went 1, 2, 3, 4, 3, 2, 3, 4, 5, 6. So it actually went backwards, and when it got to the beginning of that going backwards, it just kind of progressed from where it was. Now, I could say backwards, and that gets us that 1, 2, 3, 4, 3, 2, 5, 6 kind of pattern that we were looking for before. So that direction is it goes forwards, and then it goes backwards. And then it continues from where it left off once it was done. If we say forwards, it should go 1, 2, 3, 4, and repeat it once. So it would be 1, 2, 3, 4, 2, 3, 4, 5, 6, because we're repeating it once. So it should be there. So you can really get like a minutia of control over what the wave sequences are doing in terms of, you know, what's being triggered when and what notes next and that kind of thing. Okay, the swing resolution is kind of directly related to the swing up here, and really that swing resolution is nothing more than just by how much are we offsetting when we set the percentage of swing. I feel like the swing resolution probably belongs up here, but you know, there's not enough room, fine. So the swing resolution is exactly what it sounds like. Is, you know, when we say 100% swing, is it 100% of an eighth note? Is 100% of a quarter note? Is like what is the swing resolution? Now this note on advance is kind of neat. What it's going to do is it's going to advance the start point based off of your note. So the very first note that you play is a piano. But if I play that note again, it's suddenly the next sound or the next step, which is the organ. 3, 4, right? And if I hold it, it'll continue running. Right? So it's basically following, let me just set the direction forward and the repeat time back to infinite. It's going to follow your pattern every time you trigger the note. Right? So now it's going to repeat 2, 3, 4 forever. I could turn run off, and it still works. The only difference is when I turn run off, if I hold the note, it's going to stay on that note. Now, this note on advance, more specifically that you need to be aware of, it's based off of phrasing. And so what I mean by that is you have to let go of all the notes. So much in the same way on piano, when you play legato, you're kind of if you play one note and then you play another note, there's this duration where you're not letting go of one note and you're pressing the second note, and it's kind of like this very fine cutoff. That's how you play legato, right? Well, if you play staccato, the notes are not, one note is final and then the next note starts. So think of it as a phrasing or a tying together. Okay, so every time you trigger, it'll trigger a new note. If you hold the phrase down, okay, I'm holding the chord, well, it's in an octave on my left hand. Okay, until I let go of all of the notes, it will not proceed to the next sound. And you can do some really neat stuff that way. So that note on advance is kind of neat. So this modulation down at the bottom. So what this means, this modulation is the position. So where are we in the sequence? Now I could, again, I'm going to assign the ribbon again, and I'm going to say, let's deal with up to 3 steps. I'm going to turn run off just for a moment so you can really hear what's going on. When I play a note, when I start moving on the ribbon, okay, it's basically manually moving where in the step sequence you are. Now the thing that you need to be aware of is that there's no crossfading when you do this. This is going to be a re-trigger. So it's literally triggering everything from scratch. Okay. Now you don't have to necessarily use the ribbon. I'm just using that as an example. You could use something like LFO if you really wanted to, right? And if you slow your LFO down, well then, and again, this LFO is going to be entirely based off of the program that it's in. So if we were to go back to program mode, and I go to LFO and I turn the frequency way down, now when I go back to global mode, and it's pulling this LFO information from the program, okay, you'll notice it's way slower now. Okay. Duration is exactly what it sounds like. We're going to assign this to the ribbon again. Now, the duration, you can almost think of it as a scale, right? 100% being even across the board. Whereas if I set the intensity to 50, what's going to happen, regardless whether it's in time or tempo, it's going to change the duration by half speed. Actually, let me run it. Okay, so now if I bring the ribbon up, we're increasing it by 50%. If I bring the ribbon down, we're decreasing by 50%. Okay, so that's what that intensity means is, because the ribbon is bidirectional, it can go positive and it can go negative, it has the intensity to be able to change by up to 50%. If we change it by 100%, it actually is almost like 0. Moving the ribbon, nothing happens. If we were to set the intensity to 1%, what that means is the ribbon has the ability to slow it down to like 1% speed versus speed it up by, a large factor. So I'm sure there's something that could be used for that. That's kind of neat. So I'm just going to set that back to 100. Yeah, you could probably do some neat stuff with that. Okay, so that all being said, that's kind of covering the step, the sequence parameter page. Now that's fine because what this is doing is this is kind of like a multi-sample where you're configuring the multi-sample steps, what's happening overall. Now we're going to go to the step parameter page and look at each individual step. So I'm going to go to step 1, and we've got this whole upper section remains the same, so that doesn't change. But what does change is our resources and all of the things that we can do here. So I'm going to turn run off, and I'm just going to look at the piano. Okay, so we're on step 1, just the piano. So we've got our resources. So where it says multi here, what this is referencing is actually what is the sample doing. So in this case, we've got a multi-sample that's being triggered, and then we get to choose what multi-sample, like where is it from, what database is it kind of stored in. So is it a user bank? Is it like a user sample? Is it internal ROM? Is it an expansion? But then we also have what is the actual sample itself. So in this case, it's just the piano. So I could say multi, but I could say tie or rest. And the reason they have those here is because this is, this is a rhythmic function. You have the ability to have things like ties, where it's very much like musical notation, where you can tie from one note to another. And when you tie a note together, you're holding that note for the duration of the second note as well. And so if we hit the drop down, you can see tie or rest. And tie, what's going to happen, because this is the very first step, it's going to trigger that first step and step through the sequence. If I hit run, it's going to step through the sequence. And when it gets to the end, instead of playing that sample again, what it's going to do is it's going to take the last sample that was played and make it hold for the duration of this tie. Now what's happening is it's not hitting the end, so it's hitting 2 3 4 2 3 4 2 3 4 because I've got it on loop. If I turn the loop off though, it's just going to go straight through. Actually, so that's not going to work either. So what I'm going to need to do is I'm going to need it to go. Let's just set it for all 6, and we're going to set it for infinite loop. There. So normally where it would re-trigger the piano again, because I've got it set to tie, it's holding the last note that was played, or the last sample that was played, not playing the piano. It only plays it on the first one. But it doesn't necessarily have to be that way. You could have that on the second one. So the second sample, instead of playing the organ, it's going to tie the piano. So it's going to go ding, and then it's going to play the rest of the samples instead of playing the organ. Okay. Now you could do a rest. When you do a rest, it's actually, instead of tying the piano and holding the piano over, it's going to stop playing. And so the rest is, again, exactly the duration that's kind of specified in that step. So I'm going to set this back to multi. Okay, so we already kind of talked about the resources. Let's talk about the start offset. So the start offset, the way this works is that, here, let me do this. So the way the start offset works is that when you look at a sample, so if you've got a sample that's like, let's say this long, yeah, that long. If you've got a sample that's this long, your start offset when it's off is going to be the very beginning. Now, different samples have different offset points set throughout them. These are predetermined by Korg, so when they programmed the Kronos, they had different offset points in the samples themselves. For a user sample, so one that you might make yourself, you've got 2 offset points. You've actually got the 0 offset, which is the very beginning, and then you have your first offset, which is where your loop starts, and that's it. That's all you get. You can't program more offset points, not as far as I know anyway. But if I'm wrong, let me know in the comments below. I'd like to know. And where. But generally speaking, when you look at different samples that are available in the Kronos, some don't have offset points. So, for example, this acoustic piano does not have an offset point. It's not because it's the first in the list. It's because this sample doesn't have any additional offset points whatsoever. It is a single straight-through sample. But if we were to choose a different waveform entirely, so let's see if we can find one. Maybe the trumpet has one. Okay, so the trumpet has a few different offset points. So off is, again, the very start of the sample. First is going to be somewhere else arbitrarily in the sample. So if we listen to the difference between off versus first, they sound very, very, very similar, and it's possible that they are actually very similar. The second offset should be further into the sample, though. Okay, so you're noticing, or you may not notice, it's actually cutting off that like that beginning kind of percussive attack. Okay, and then the third, it sounds like a trumpet, but it's none of the attack at the beginning. So this offset allows you to choose where in the sample you're actually starting the sound from. And again, it's going to be predetermined by Korg and the samples that are being used. We've got REV, which stands for reverse. That's exactly what it is. It's taking the sample and playing it backwards. We've got transpose. Actually, let me get back to the piano here because this is going to make more sense this way. We've got transpose. And transpose is, you can think of it like this. Imagine I had 3 rubber bands and I'm pulling them tight, and they were differently tuned. Okay. Transpose is using one key to play a different elastic band, right? So you've got samples, you're using a key to transpose. It's almost like taking your whole keyboard and shifting it. Okay, so there's a little Simpsons for you through transposition. Okay, I played the same key every single time. Now, tuning, you can tune up to an octave. Now, the problem with tuning, it's actually not a problem. It's actually a very useful technique. When you tune versus transpose, transposition uses a different key on the keyboard to trigger the note, even though you're playing the same key. Tune is like taking those elastic bands and stretching them or shrinking them, right? You're actually changing how the sound works. So if you listen to the piano, and I were to tune it up an octave, or down an octave, okay, that's different than how it sounds if I were to transpose it an octave. So this is no different than me playing C5. Okay, so now I'm going to play C5. Okay, sounds the same. Now if I do tuning up an octave, I'm going to play C4. It's triggering the note on C5, but it doesn't sound the same. The formant is different. The timbre is different. Versus, okay, so tuning actually will stretch and shrink the sample, or almost change the playback speed so that it changes the tune and the pitch, but that also changes the timbre. You can actually use this to your advantage, though. If there's a particular sound that maybe you want intentionally to sound a little bit thinner, you can tune it up, right? So you could tune it up like 700 cents and then transpose it down 7 semitones. I said 7 down. And that's going to sound different than, okay, so it changes the formant. If we wanted to make it really obvious, I'm going to transpose it down an octave, but tune it up an octave. And so when I play C4, it's still the piano sample, but it sounds different. So you can actually use this to your advantage. There's some neat stuff that you can do with it. This level, the level parameter, is the volume. That's it. That's all it is. Duration is exactly what it sounds like. So the duration is going to be how long does the note last. Now, when we're in time mode, it's going to be based off of milliseconds. When we're in tempo mode, it's going to be based off of the internal clock of the Kronos, subdivided by quarter notes, dotted eighth notes, and so on and so forth. But there's also this cool option that says gate. And what gate does is gate will not play the next note until you let go of the first. I don't have run set. And you can't hear it anyway because, well, because why? Oh, I'm on the wrong page. Did I solo something by accident? This is on infinite. Okay, it's really hard to hear, but you can kind of hear the organ as I'm letting go of the note. Okay, let me try this. Let's set this up like this, where we've got a gate on the second note. Okay, so the way the gate's working is that the gate won't continue until you let go of a note. Okay. You do have the ability to set the duration as well. So you could say, so let's say I wanted a quarter note. Well, maybe I'd want the quarter note to last the duration of, sorry, this is an eighth note. Maybe I want it to last the duration of a quarter note. Well, you could just set a quarter note. Or you could say, I want it to be twice as long. Okay, so you can set like how long the duration is. It's almost the same thing as doubling your duration or tripling it, and like that kind of thing. So now we get into things like crossfade. So crossfade, the way this is going to work is this is going to crossfade the end of the sample. And then you have your fade in and fade out shapes, which is either linear, exponential, or logarithmic. So the crossfade. In terms of milliseconds, so if you have it based off of time or tempo, it's really, it doesn't matter so much. Oh, one thing to mention is this button down here, it's expand compress, is only available in time mode. And basically what it's saying is how much are we expanding or compressing by. So if we were to say expand or compress by 100%, well, it's not going to change anything. But if we said expand or compress by 50%, we can hit OK. It's going to change. It's basically going to subdivide everything by half. We could say expand it by 200%, and that kind of puts it back close to where it was, right? And then we also have this option that says keep proportion, and that's going to keep things proportional to one another. So if you've got different values throughout the entire thing, that's what that's going to do. Okay. But we're back in tempo mode. And so you can do the same thing where you can say, well, I want to divide all these times by 2. And so if we've got 1/8 notes, that's going to change them to 16th notes. If we multiply it by 2, it sets them to quarter notes, or basically doubles or halves the time that we've got set. And there's no need to set proportions, because if we had something as a dotted triple and we say we want it to last twice as long, well, it's automatically going to do that for you. I have a tendency to just leave everything the same, kind of like a step sequencer would be. So I know in step 5, if step 5 needs to tie into step 6, I know that there's still 5 and 6. So I can keep the total duration of things consistent, as opposed to trying to mathematically figure out, well, I've got a quarter note, which is 2/8 notes, and then I've got 4/16, which is like a quarter, and like trying to do all that math. You can keep things a little bit more simple that way. Okay, so our crossfade, as I was mentioning previously, this is the crossfade at the end of the sample. Okay, so if I have a crossfade that says, 200 milliseconds, for example, this piano is not going to crossfade until the second repetition through. Oh, well, I'm lying. It's actually at the end of the piano sample. But a lot of people will think, well, how come the very beginning isn't? What I was trying to illustrate was the very beginning of the piano sample isn't going to crossfade. The intro or the beginning of the piano sample, if you wanted that to fade in, it's only going to fade in at the end of the loop. So for example, this crossfade here at the very end that says pop ooh, if I were to set that to 200 milliseconds as well, that will crossfade on both ends. Okay, so this is basically saying, well, crossfade the beginning and the end. More specifically, when you actually look at the sample, it's crossfading the end. But we do have the ability to set the crossfade for everything. And this is going to make it a little bit smoother to move through. The exception is the very beginning piano sample. That doesn't crossfade in from anything. There's nothing to fade into from. Like there's nothing, there's no end sample that it crossfades into the beginning. So it's going to trigger the piano right away. Right? So it's triggering it like it normally would. Now that being said, you do have the ability to go into program mode and change the ADSR on your attack and increase it. Now right now, there we go. This is just the init program, right? This isn't actually the wave sequence. So what I'm changing isn't anything it's not anything important here. It's not anything directly related to the wave sequence. But you could actually increase the attack time to get that fade in on that first sound as well. So you'll notice it's actually fading in the piano. And the reason it's doing that is because when you're in program mode, we're just using whatever the default sound is. However, when we're in global mode, the wave sequence pulls all of its information from the last program that you had accessed. So if I were to insert effects, for example, and I were to put, let's say, a reverb on here, I have to route it properly really quickly. Okay, so now that there's reverb on it, if I go to global mode, now there's reverb on it as well. It's just kind of how the Kronos works. So I'm just going to turn that reverb off. I don't need it there. I just wanted to give that as an illustration point. Okay, so we've got our crossfades. Now the next thing we're going to take a look at is our fade in, fade out. So when it's referencing like linear versus logarithmic versus exponential, it's basically saying mathematically what is happening to the fade out, fade in. So on the fade in, is it fading in quickly? Okay, so if I were to kind of do this backwards here, is it fading in quickly? Is it fading in linearly? So like linear is like from here to here. If these are your 2 points of reference, this is 0 and this is 100% volume. Linear is, like a 1-to-1 ratio. Is it climbing up evenly the whole way? Exponential is it climbing up quickly and then fading out? Sorry, I have it backwards. Or do I? Anyway, one of them, logarithmic, I believe the logarithmic starts like high really fast and then kind of flattens out, where exponential starts low and then gets really high. So it's basically, is the curve straight? Is it up and then over? So does it get loud quickly and then stay kind of loud, or does it stay quiet mostly and then get loud quickly? And so there we go. That's what that fade in, fade out shape is talking about. So if we were to set it to exponential, here's what I'm going to do is I'm going to increase the time. I'm going to set it by time. And we're going to say it's going to take 1 whole second to fade between these two. And I'm just going to use those two so I can kind of step back and forth between one another here. Okay, so the point that I'm trying to make is with exponential, you can hear it go, but the rest of them, it's kind of linear. It's kind of an even transition. Okay, so exponential sounds kind of like it's staying quiet and then gets loud very quickly. If we were to change this to logarithmic, here, it should, as far as I understand, get loud and then stay. It sounds like it gets loud very quickly. Yeah, so it's kind of trying to ramp up the volume quickly and then stay loud. Versus linear, which is just a straight transition back and forth. Okay, so finally, this last point that I wanted to take a look at was this AMS. So AMS out, what this gives you the ability to do is this AMS is more or less, during this step, we can send AMS values to something. So for example, we could send it to a cutoff filter or resonance or pitch or whatever we want. And so maybe for the acoustic piano, maybe I want the filter cutoff to be more bright than I want the organ to be. So what I could do is I could set AMS out to, let's say, 50. And you can see it goes up to 127 as max, right? So I'm going to set it to say, well, let's say 64. That's kind of halfway. And so what I can do is I can say 64 and then AMS out 0 for the next step. So what's going to happen is in the wave sequence, when the first step is being processed, it's going to send a value of 64 to the program as a modulation value, and you can assign that to stuff. So it's got a modulation value of 64. When it goes to the organ, that modulation value is going to drop off. Okay, so what that means is when I go into program mode, I can go to the filter, and actually this is going to make more sense if I assign this as a wave sequence. So in program mode, when you tap on the oscillator page, right, oscillator basic, you can choose wave sequence here, and this is actually how you determine what the wave sequences are. So actually, let me save this. Oh crap. Maybe it saved it. Maybe it didn't. I don't think I saved it. You know what? That happens. I'm going to recreate it quickly. This is easy. 250, piano, and I chose organ. Gentle reminder, save your work, folks. Here you go. Right, and I'm just going to call it test, if I can. Test 1. There. So I've got my wave sequence. I've got my AMS out. Okay, it's not quite what we had before. We wanted that at 250, 250. Good enough. Okay, so point being, multi-sample the piano. We're going to send this AMS value out to the program. Okay, so I save that because I've done that way too many times. Okay, so now what I'm going to do is in this program, I've chosen wave sequence, and I'm going to choose my test that I've created earlier. Okay, so far so good. Now if I were to listen to it, notice it's twice as fast because it's pulling from the global tempo of the Kronos. So if I set that to 60, it's more like what we had before. Okay, so the question is then, well, Dave, you said you could assign the filter cutoff using the AMS as a source, right? Well, what's cool, so we've got our filter, and I'm actually going to make it just a low-pass filter, and I'm going to set the frequency down quite a bit. Okay, so this is affecting both, right, the organ and the piano sound. Well, remember I said I wanted the piano to be like maybe more cut off or less cut off. I can choose that. Under the filter mod page, this is where we can set the modulation sources for the filter cutoff. So this is where it's kind of like, think of it backwards. We're telling the filter to be modulated by something. So in this case, we've got filter A modulation. There is no filter B, it's only a low pass filter. And by default, I've got a couple that are set here. So I'm going to represent this AMS1. Instead of joystick X, I'm going to choose, where did it go? Here it is, wave sequence AMS out. So this wave sequence AMS is pulling from that value that we had set previously up here. This AMS that says 64, that's what we're basically sending that value of 64 to the filter under the filter mod page and the intensity. So we're sending 64. Now, if I set the intensity here to 50, we're doing 50% intensity of 64, so it's actually a value of 32. If I set this to 99, that's basically the equivalent of 100, which means this wave sequence AMS is going to be able to control the filter by a true value of 64. There's kind of a ratio relationship there. So what should happen now is as it cycles through, right now the frequency is at 48. When the piano plays, this frequency should actually be modulated by 64, which will bump it up to be completely open. Let's get a different sample here, actually, because this is kind of hard to hear. I'm just going to save the program really quickly. So user FF 000, and I'm going to get a different sound that's a little bit more, it's got a little bit more harmonic content to it. So that's going to be easier to hear. Actually, probably getting rid of this crossfade might help too. Okay, so watch what happens if we were to change this, this AMS out. Okay, so what we've done is we've taken this AMS and sent it to the filter and told the filter, okay, when you're filtering things, use AMS, use your wave sequence AMS out as one of the valid sources and give it lots of intensity, give it full capability. And what's happening is as I'm modulating this AMS out, we get to control what the filter is doing at every step of the level. So if I were to choose, let's say I were to choose, make it 4 steps long. So we've got 4 steps, and now I'm going to choose piano, string, guitar, and then something else. Synth wave, like, let's go the synth lead Pro 5 here. Okay, you'll notice these last 2 are filtered, but we can fix that. There we go. And so this gives us that ability to like choose what's happening inside the program during each step. So you can actually assign AMS 1 and 2 as its own value, which is really, really cool. Now, one of the things that I said I was going to come back to and review just before I kind of wrap up this video, because this is a lot of information, was the solo button. So the solo button allows you to listen to a step completely independent. So I'm going to set this as 256 or 250 millisecond crossfade. Now remember how I had said earlier that the crossfade happens at the end of the sample? Well, that's absolutely true. This guitar is re-triggering, and if I were to hit solo on step 3, which is what I've got highlighted, you'll notice if I choose step 2 or step 1, it actually changes up there automatically for me. So it's soloed. It's going to show me how this is behaving. Okay, so I can hear how fast it's crossfading out, whether it's linear or not. So maybe I want the crossfade out to be exponential. Or maybe I want it to be -127, which is logarithmic. So it stays loud and then gets quiet quickly. Okay. So you can hear exactly what's happening. Now, if I wanted the nylon guitar to fade in, I would actually have to go to the step prior and tell it at the end of the string quartet to fade out. So if I go back to the guitar, you can hear it. It's fading in and out now. So you have a lot of control. When you hit the solo button, it allows you to hear exactly what's happening during that specific step. So if you're going, well, I think it's doing it. See, it can be really convoluted if things are moving really quickly. And so by hitting solo, it just isolates that one step so you can listen to it by itself. So finally, going back to program mode, one of the things that I wanted to mention is steps that you do in the program that are related to this layer. So for example, wave sequence. One of the things you can do in the HD1 engine is you can layer stuff. You can have up to 2 layers happening simultaneously. So if I were to choose like a saw as well. Okay, so the saw is technically part of the oscillator that's happening here. Well, the reason I mention this is I actually came up across this a couple of days ago when I was experimenting before I made the video, is that what I was expecting is that this filter was going to change based off of the settings that I had in here. Now, what actually happens is that those filter settings only apply to this sound itself. This saw doesn't change. So if we were to turn the level down, for example, I'm going to turn the volume on the wave sequence off, you'll notice the saw does not change the filter frequency, the cutoff. It remains the same. So while this wave sequence applies a change to this to the cutoff of the filter, it only applies to that layer, even though these are technically layered together. You'll notice if I bring the level volume back up for the wave sequence, even if I bring it really low, okay, so that's something that you need to be aware of. If you're expecting, one of the things that I was trying to do with it is I was trying to go to the wave sequence, and what I wanted it to do is I wanted the AMS to actually control the cutoff frequency for that entire oscillator, but it doesn't work that way. It only applies to that one layer. So that's just something that's kind of like a caveat that you need to be aware of. Okay, so I think that's pretty much it. I believe I've covered just about everything. So what I would say is your imagination is, the limit. Like, go nuts. Find out what you can do with this stuff. You can assign a lot of percussive stuff to it, make some really cool rhythmic patterns. You can do like a lot of arpeggiation kind of stuff. The other thing that you need to be aware of, and I had recorded this video previously, and then I got partway through and I hit the wrong button, and people were looking at the wrong stuff and it was terrible. So anyway, I re-recorded this, and one of the things that I had mentioned in the other video that I wanted to mention this time as well is that because of how this is set up, right? One of the things that people will often do is they'll say, well, I've got a sound and I want it to do a specific rhythmic pulse, right? So it might be right? The problem is if you have a sound already built, there's no way to reverse engineer it backwards into the wave sequence. Now, what you can do, however, is you can, in the wave sequence, if you can get the sound close enough inside of the wave sequence, then yes, you can do things like, let's just rest this first sample. We'll get rid of the crossfade for everything. And I'm going to make these all piano, just so it's a little bit more percussive, right? So we can hear what's going on. And I'm going to make it go pretty fast as well. Here. So we're going to set the BPM like to 180. I'm going to try and set the BPM to 180. Okay, let's just crank these up. I want the filter open for everything. So it's going bit. So that's that rest that I'm making the sound for. So let's say that's the rhythmic pulse you want. Well, if you've got the sound already made, you can't reverse it, right? Like you can't take the sound that you've made and put it in the wave sequencer unless you were to sample it. And you do have the ability on the Kronos to sample itself, right? You can hit the sample record button that's just right of the tempo knob. So you can hit the sample record and then hit start stop. And as soon as whatever you play, while you're playing stuff, it's going to record. And then when you hit the start stop button again, that's going to be the end of the sample. So you could technically make a sound, sample it, and then import it as a wave sequence or something like that and trigger it that way. But another thing that you could do instead is, let's say I've got a bunch of saw waves, right? And I've got like, I wanted to make this really techno sounding kind of saw, right? Well, one of the things about saws with a lot of techno music is that they're often heavily detuned. So what I could do is I could write my wave sequence. And so I've got a bunch of saws that have the pattern I want. Okay, so it's going da-da-da-da-da-da. Actually, here's what I'm going to do. Maybe I want some rests in between them, right? So maybe I don't want it to be so da-da-da. Maybe I want it to be da-da-da-da-da, like a little bit more staccato. So what I'm going to do is I'm going to set my parameter to 8 instead of 4. So I'm increasing the number of steps. And what I'm going to do is I'm going to have a rest every, well, it should be, if I'm doing this correctly, it should be rest, rest, saw, rest, saw, rest, saw, rest. I think we're going to try that. Saw, so this is 1086. 1086 for your saw. There. And then if I want to rest, I'm going to say rest, rest. Let's hear what that sounds like. Okay. And so rest, sound. Okay, so that's what I want, but it's too slow. So let's increase the speed. Okay, good enough. So that's okay, fine. I've got the rhythmic kind of pulse that I wanted. And I'm going to write it, and that's good. Now what I'm going to do is in program mode. So I've got this. Yeah, let's increase the speed. It was 180. Okay, doesn't sound great yet. What we can do is we can actually add a second oscillator. So we can say we're going to set this to double. And we'll go back to play, and we're going to choose the same wave sequence, which is our saws, this one. There we go. But here's what we're going to do is we're going to tune this layer down. There we go. So that's starting to sound a little bit more techno-ish, if that's what you're going for. So I've got different filters for stuff like that. Let's keep this low pass with a little bit of resonance. And if we really wanted to be picky, we could pan them left and right a little bit here. So I'm going to do that just for sake of, right? If you're going to do it right. Ooh, that sounds kind of nice. And then what I can do is I can say unison, and we're going to set the stereo spread to about 50 or so. We'll set the thickness on 2, and we'll set the number of voices to 3, and then we'll set the detune quite a bit. And I need to bring the volume down because once you start adding more oscillators, things get loud, right? There. And so you could feasibly make the sound that way by taking a couple of your wave sequences that are the exact same and then manipulating them in multiple programs, panning them, fading them, setting different ADSR for them, that kind of thing. So anyway, I've spoken quite enough. There's a lot of information there. If you have questions, put them in the comment section below and I'll try and get back to you as soon as I can with a question, with an answer rather. Otherwise, I hope you enjoyed this video. It's been long and I hope to bring some more to you. So thanks for watching.